The last lesson on exponents has to be about writing exponential growth or decay. And this is a lesson that's a lot of review from Algebra 1. So basically, we showed you with an exponential graph, you can either grow or you can either decay. So increasing or growth, obviously. The formula is this. Q, and then parentheses 1 plus p to the t power. Well, what do all these things represent? Q sub 0. That means initial. That's why it's called ground zero, not to bring up a bad memory, but sub 0 is to begin. P is the percentage. You're always going to be growing or decreasing by a percentage. And then T is going to be time. And that's probably where you're going to have to read carefully. They may say the problem is in weeks and then ask you to answer it in months. That's not the hard part. It's just catching it. You can convert weeks to months. No biggie. What does get kids is the decrease or the decay. Because everything is the same. You have Q sub 0, in other words, your initial investment, but then your percentage has to be subtracted from 1. Most kids just put the percentage in. And when we do a decreasing model, I'll explain that some more. So here's exercise 1. Suppose you deposit money into a savings account that receives 5% interest per year. So right now I'm going to drag this out, and I know P is 5%. The amount of money that was in the account, assume you deposited $400. Well, that's your initial investment. Q sub 0 is $400. How much money is in the savings account at the end of 1 year? Well, that's the formula. Now remember, an exponential formula is f of x equals a times b to the x. Well, you're doing the same thing with exponential growth and decay. Except in this case, we're looking for our savings, where A, I kept calling that principal so you get used to it. So we started with $400. But our base in this is 1.05. Because remember, it said when we were doing increasing, we take 1 and we add the percentage onto it. Well, why do we do 1 plus? Because 1 represents that you get all of your $400 back. And that's what the decimal means. You get 5% more of that $400. And then it's raised to some time frame. So if we were to figure out how much is at the end of 1 year, it's very simple. Our savings is $400 times 1.05 raised to the first power. And then we could just get our little handy dandy calculator. And let it do the work. 400 times 1.05. We don't even have to put to the first, but I'm going to. You'll have $420. And then how much at the end of 5 years? Well, I think you get what you do. 400, still growing at a rate of all your money back and 5%. Now raise it to the 5th power. So I'm going to re-grab that, and I'm just going to change that 1 to a 5. I'll have $510.51. Now, for this next one, we talked about this in class the other day, about how long it should take your money to double if you have a good investment. Maybe you remembered my answer. But anyway, how long will it take your money to double? We're going to have to look at a graph to answer this question because you don't know how to solve it algebraically yet. That's the next chapter. But what they do want you to realize is that if you started off with $400, it was growing at a rate of 1.05, raised to some power, you want that to equal 800. Now, I could graph that, but I'm going to have to look at a graph that's pretty high. So I'm going to clean this up a little bit by dividing both sides by 400 to make my numbers smaller. 1.05 raised to some time frame should get me the number 2, because how long is it going to take for a percentage of 5% to double? Well, I'm going to go to Desmos to make my life easy. Clear out some old stuff I have in there. And over here, I'm going to type in 1.05 to the x equals y. And then I'm going to type y equals 2, because that's what I want it to do. I've got to adjust my window. I had my window really zoomed out, so I'm going to come in here and I'm going to make it from 0 to 10, up by 1. And my y-axis is going to go from 0 to, well, we can go to 10 also. I'm going to step by 1. Come back over here. And there we have it. Remember now, my orange represented my exponential, and my black represented my y equals 2. So if I just follow this along, where are my two graphs going to meet? Wow, all the way out here at approximately 14 years. If you remembered, that's not really a great investment. You want your money to double in at least 7 to 10 years, not 14. 5% is not a great rate. You want your rate to be, you wish you could get 10%, but the market generally gives you around 7 to 8%. Example 2, if a population is decreasing, here's that decreasing one, by 4%. So my percent, most kids think it's 4%. We're going to show you a little trick to that. It started with 12,500 residents, so according to this, our initial quantity is 12,500, and it's an exponential model. We want to know what its population will be in 10 years. So if I go to write this, the population is, start with 12,500, but remember, when I am doing decreasing, it told me to do 1 minus my percentage. I just don't put in 4%. I put in 96%. Because every year it's only maintaining 96% of what it had. So think about it. If you had $1, and then I told you next year you're only going to have 96 cents of that dollar. Okay, now you're down to 96. Now the year after that, I told you you're going to have 96% of that 96 cents. So you're not getting all your 96 cents back. You're only going to get about 85 cents. You're losing. That's what depreciation is. So that's the trick to decreasing. You don't really write down 4%. Immediately you subtract and you say, I'm only keeping 96%. It's not 1 plus 96 because I'm not maintaining all of my 12,500 people. I'm going down. And then the last thing they wanted me to do was put the number 10 in. Well, that's pretty easy to do. That's just calculator work. 12,500 times 0.96 to the 10th. So in 10 years, our population is going to be down to 8,310 people. Our last one, stock pricing. So we have wind power increasing Okay, we like that, at a rate of 4%. So if we do wind power over here, its percentage is 4%. I like to put a plus there to remind myself it's increasing. On the other hand, we have gerbil energy. Oh, aren't they clever? Like a little hamster in a wheel. And they're crashing, losing value at a rate of 11%. So their percentage, remember, is not 11%, but it's actually 89%. And I'm going to put a little minus there to indicate that it's losing. If its price was $120 per share, so its initial price was $120 per share, and the wind power's initial price was $20, after how many weeks will the stocks be the same? So when they say be the same, I want to set up two equations and set them equal to each other. Well, since this is exponential, we know that the wind, initial cost of $20, growing, so that means 1, I get all my money back, and I get 4% more to some power, is going to equal our friend the gerbils that started off at $120, but they were decreasing, losing 89% per year. Oh, sorry, per week. Wow, this thing is just in a free-for-all. So again, we don't know how to solve when the exponents are unknown. Next chapter, but we can clean it up before we put it on a graph. I'm going to divide this by 20. I'm going to divide this by 20. That leaves me with 1.04 to the t equals 6 times 0.89 to the t. And again, we only know how to do this graphically, so we're going to go over to Desmos, and we're going to put those graphs in and see where they cross. Okay, so our friend the wind power, 1.04 to the x. And then our friend the gerbils, which is 6 times 0.89 to the x. Oh, they cross in a nice spot right there. 11.504. Well, actually, 11.5 would round up to about 12 weeks. So again, it's an approximation, but I wouldn't even wait it after 2 weeks. Once I saw that stock dropping, boom, sell it, baby.